Hello, welcome to India's most comprehensive e-learning platform, BYJU'S Exam Prep. Myself Phanindra, I am here to present the subject called Process Control Instrumentation. In this evening, we all have gathered together to discuss the concept of types of control valves. In fact, this is the third series lecture in control valves topic. Up to now, I have already handled two different lectures on control valves. Starting from the basics of the control valves, we have all the way traveled so much and came up to here. I hope those students who are attending regularly the classes, they might be really enjoyed a lot. Well, good evening to all. Good evening Kajal Sharma, Neha Srinivas and Gunakumara, everyone. Good evening to all. First of all, before going into the actual topics of control valves, I would remind this point to all of you. Those who want to excel the topic of control valves, please go and watch the previous two lectures. Then you come to this lecture and I am very sure you will love this lecture. Well, before going into the actual topic, let me briefly introduce about myself. As you all can see on the slide, all put together, I have 11 plus years of teaching experience and I have taught in almost all coaching centers in India, of course, very famous coaching centers also. And up to now, I have guided more than 50,000 of the students in the subjects of control system, circuit theory, measurements and industrial instrumentation. So, I am specially known for the industrial instrumentation topic. Let us go to the topic of types of control valve without wasting any further time. So, before getting into the topic, I just want to give a recap of the concepts what we have discussed so far, because many students are about to join and some students are joining. So let's quickly have a revision section for 5 to 10 minutes on the previous topics what we have discussed. Well, in the previous lectures, we have started our discussion from the very much fundamental on the control valve. What is control valve? And how does this device is very much important as far as the process industry is considered. And we have seen the internal construction of the control valve very clearly in the first lecture of the control valve. And then I have taught the characteristics of the control valve, and then we have seen how we can divide or how we can classify the control valves based on the characteristics. And during that discussion, I have clearly explained there are three different types of the plugs are possible to show you the three different way of flow characteristics. One among that was a quick opening valve. I hope you remember this. Hello sir, yes, hello, hello. And the second one was, what is the second one? Second one was a linear valve and the third one was equal percentage valve, right? So these three valves already we have discussed so elaborately. Again I am repeating this: quick opening valve, and second one was the linear type valve, and third one was equal percentage valve. In case if any one of you missed these sessions, I sincerely request please go and find these lectures in the same playlist and explore those concepts before going to the topic of types of control valves. Clear? Of course, after completing these three, in fact in the very previous lecture we have discussed a very popular concept that is called valve sizing. Being an instrumentation engineer, valve sizing is considered as one of the very important topic, not only for the GATE examination, even if you go for the process industry for an interview, or if you want to work in PSUs, definitely you have to know the concept of valve sizing. And I have started from the basics of valve sizing and I have covered all the topics related to the valve sizing in the previous lecture. So in this lecture, we are only concerned about the types of control valves. But before going to start this topic of types of control valves, I would remind this point to everyone. This topic is a very open, and this topic specially, it is very wide. If you go to industry or if you go to manufacturer, you will find several types of control valves. Of course, it is highly impossible for any teacher to explain all types of control valves. I have done my best to summarize the maximum themed control valves in this lecture so that you will understand the basic concepts clearly. Clear? So, let's get into the topic. All of you are ready for the today's session? If you are ready, please mention that yes, you are ready. So, your energy is directly proportional to my energy. Okay? Well, getting into the topic, how do we divide or how do we classify control valves into many different types? Clear? The very first thing is, based on the flow characteristics. This was already discussed. However, I will quickly revise that. And then based on the shape of the plug and construction. As I have been continuously saying, in every control valve, we will have a valve plug. And depending upon the shape of the plug, the flow characteristics will be different. And this was also discussed to you. So the major portion was already discussed. But continuation to that, we need to discuss the remaining types also. Okay. The third one is based on the number of plugs. And fourth one is actuation method used. And fifth one is directional control valve. Clear? So, summing all these things, if we keep it abstract level, you will understand that 5 different types of control valves are there. Clear? So, now let me quickly revise about the control valves which are classified based on the flow characteristics. Now, you all can see on the slide a simple control valve is there, and you know that the input flow rate can be given as a Q in here. However, the output flow rate here must be mentioned as a Q naught here. Correct? That you already know that. Depending upon the position of the valve, the output flow rate will be regulated. This was also discussed in the previous lecture. And you can see the output flow rate is clearly mentioned in meter cube per second, and the output flow rate will be adjusted or regulated if you change the position of the stem. So if you move the stem up or if you move the stem down, based on the movement of the stem, the area of opening here will going to change. Because of that, the output flow rate will be regulated. This is what we have discussed in the previous lectures. However, many students and many control engineers, they are very much interested to understand how the output flow rate and stem movement both are related. Correct? So, if you frame the relation between the stem movement and the output flow rate, that relations will show you clearly the flow characteristics of control valves. Clear? So, in a single shot, what should I say here? The variation of the fluid flow rate at outlet and the stem movement is termed as a flow characteristics. This is what I told you even in the previous lectures also. Flow rate and stem movement, both of these two are related. And if we show the variation of these two, then we call that as particularly we call that as a flow characteristics. Clear? So hope you enjoyed this topic, right? Of course, we have defined several variables here, and we have defined a very popular variable in flow characteristics, that is equals to M, which is equal to output flow rate divided by the maximum output flow rate that can flow through the pipe or that can flow through the control valve. Suppose for example, at any case, let us say the output flow rate is equal to 10 liters per second or 10 meter cube per second, and the maximum flow rate, if I take 100 meter cube per second, then what is the value of M here? So this is a 10 meter cube per second here, and divided by 100 meter cube per second, all put together in a simple language, it will going to become like 0.1. Sorry? Yes, that's correct. So this is how we have defined the value of M, and we have also discussed in the previous lecture about the value of X also. Correct? What do you mean by X? X actually informs the stem movement versus the maximum possible stem movement. Suppose if the stem movement is 20 centimeter and the maximum possible stem movement is 100 centimeter, then we will take 20 divided by 100, which is equal to 0.2. Clear? And if you draw the graph between stem movement versus M, then that particular graph is called as a flow characteristics of control valve. And we have discussed almost 40 minutes on this topic in the very first lecture of the control valve. Of course, you can find those videos in the playlist. Right? How are you, sir? Yes, I am really fine. Yes, Madhuri, good evening. Right. Moving ahead, what were the control valves we have broadly discussed on the flow characteristics? First, as I said, the graph between M and N, M and X shows the inherent characteristics of the control valve. Of course, based on the plug or based on the shape of the plug, the flow characteristics will going to change. And in the process of defining the shape of the plug, we encountered 3 different plugs or the 3 different structures, isn't it? So the very first one is quick opening valve. We have seen how much sensitive this is. For a small stem movement, we have seen the great amount of the fluid flow rate. And after that, we have even discussed about the linear type of control valve, where we have found that the stem movement and the fluid flow rate both are linear. And then we have even discussed about the quick opening control valve, and I have equal percentage type control valve, and I have clearly given an explanation about the equal percentage valve. However, that was a very big explanation. Correct? So these things very widely and greatly and deeply we have discussed. Now, moving ahead to the next topic, that is based on the number of plugs. So, I just want you to note down these things so that you will understand the flow of the subject or flow of the topic clearly. This is completed, right? And now we must go, in fact, this is also completed. Based on the shape of the plug only, we have divided like linear wall and quick opening wall, and then, equal percentage wall. Based on the construction, we have to discuss about that, we will discuss that. Now, we will see how the control walls are in fact divided or classified based on the number of plugs. So let's move on to the topic straight away here, and this is the need of the hour, and I am sure that from this slide onwards everything is new to you. Okay, I have completed the revision as I promised. In 10 minutes I have done that. Okay, now what do you mean by single seated wall? Any one of you just see the diagram here and try to guess what you mean by single seated wall or single plug wall. Anyone? I want to listen from your side. What do you mean by single seated or single plug? In a very simple language, you can find that there is only one plug here, correct? If you have only one plug, simply speaking, that will be called as a single seated wall, correct? And how does the flow rate will be regulated? First of all, let me write down this as the input flow rate here. Every one of you know that. And let me call this as the output flow rate. Okay. Well, Jagadish Jaga, yes, hello. So the output flow rate can be simply put it as meter cube per second. No doubt about this, right? Now, if you want to change the output flow rate, we will change the stem here, correct? So the stem can be moved in the upward direction or downward direction, correct? And for this stem, especially in the shape of the control wall, we will have the diaphragm like this, correct? This is the diaphragm, and I have told several times that we will apply the pressure on the diaphragm here. Suppose if you apply the pressure on the diaphragm here, assume that we have applied some amount of the pressure here. If you apply pressure, then automatically the stem will go in the downward direction, correct? And when the stem is moving in the downward direction, then this wall plug will all the way, it will close the wall here, and then the output fluid flow rate will become 0. These concepts, I am sure that you all are very familiar about that because number of times I have discussed that. Now, I would like to put a question to you. Just imagine a situation when we have a single plug here. What happens here? So the fluid, all the way it will come up like this. So let us consider that these are the fluid particles, and unfortunately they cannot straight away go like this, right? So naturally what happens at the obstruction, look at that, at wall plug, as there is a obstruction here or the sudden obstruction, some amount of the liquid will try to come back to the same channel. That means the liquid particles which are there here, naturally they will be pushed backward. This is the reason why what will happen? There will be a pressure drop, correct? I repeat, pressure drop. So what happens here is, as these particles are accumulating here just below the wall plug, before they are either moving to this side or this side, they will apply the upward thrust. That means the particles which are accumulated here, they start applying the upward force. This means that because of the fluid particles which are accumulated near the wall plug, obviously we will be getting upward force. So what will happen now? When the upward force is generated by the particles or the fluid particles which are accumulated just below the wall plug, naturally we require great amount of excess pressure, correct? So we require more amount of pressure here, correct? So what does it mean? We require to apply more amount of the force to bring the wall plug in the downward direction or to close the wall. That is the biggest challenge here. I repeat, if you want to close the wall or if you want to bring the wall plug almost to final position, then we have to apply more amount of the pressure or more amount of the force. Clear? Namaskaram sir, namaskaram. Okay, so that's the whole story here. Now putting all these things, what should I say is, the advantage of the single seated wall or the control wall is that it can be fully open and fully closed. As I said, if you bring the wall plug to the upward direction, then maximum amount of gap is there, then the fluid will all the way flow like this. Suppose if you shut down or if you put that plug near to the seat, then the wall will close and there will not be any fluid that is coming outside of the pipe. Clear? Now, what is a great disadvantage? Okay, anyway, we'll see that. Don't worry about that. So first thing is, the output flow rate can be varied from 0% to 100%. What does it mean? 0% means it is fully open state, 100% means it is fully closed state. Very simple. Okay. Now what is the disadvantage of this? Look at that. This is beautiful. The disadvantage is, if we require to apply heavy pressure at the port, that means here, I already told you, generally we will apply some pressure here, but in this case we need to apply extra pressure here. Why so? Because the particles which are accumulated at the bottom of the plug, they will try to apply the upward force. To overcome that, we need to apply the extra pressure here, and that is the greatest disadvantage in the single seated type control valve. Now every one of you, whoever understood this, please keep in the comment box whether you are following the class or not. Okay, how to bring upward, sir? Up to get it upward, it is very simple to understand. Here the air particles will be there because you are applying, it is a pneumatic type control valve, right? So there will be a chamber which is called as a cap of the control valve. Inside that you will be having the air molecules, and air molecules are pushing the diaphragm. Suppose if you want to bring it in the upward direction, you have to remove these air molecules from the chamber by using some kind of pumping techniques. Clear? So we will pump the air outside, or we will suck the air. When we suck the air, then automatically the diaphragm will move up and the stem will move up and the area of opening will be good enough. So Ritvik, is it clear to all of you? Yes. Sir, will this be the last lecture? Yes, this will be the last lecture on process control instrumentation, especially on control valves. However, based on your demand, and if you require more number of classes on a particular topic, you can keep those comments at the end of the live section. At the end of the live section, come to the comment box and keep what is your requirement. And if more students are demanding the same, then definitely we will go for the lectures on instrumentation also on live. Clear? So this is about single seated valve. As I said, this type of control valves are specially suited for only the lower flow rates. Why only for lower flow rates? Have you seen that generally the flow rate Q is directly proportional to under root of differential pressure delta P. Correct? So if you want to measure the heavier flow rate, so if you want to go for more amount of fluid flow rate measurement, then obviously we have to keep delta P is also very high. The differential pressure is also very high. But unfortunately here, if you go for maximum amount of the pressure difference, then there is a huge choice that, or huge chance that we will come up with a permanent pressure drop. This is the reason why we limit ourselves to use this particular valve for lower flow rate. Clear? So that is the idea, simple to understand. Now moving ahead to the next one, that is double seated type valve. So you can easily find out on the figure, there are two different plugs here. Of course, this is called as a plug 1 and this is a plug 2. Now, immediately you should guess and put what is your answer in the comment section. What exactly you are understanding from the figure. It's very easy. When you have two plugs, what will happen? How do you overcome the problem that we have faced in the previous slide? In the previous slide, we have discussed about single seated valve, isn't it? So we have understood that because of the accumulation of the particles, fluid particles, we are getting the upward force. How does that can be managed here? In a very simple language, what happens here is when the fluid comes all the way here, so look at that. Some amount of the fluid will all the way come like this and some amount of the fluid will all the way come like this. Correct? Now great part here is the fluid particles which are accumulated here, they will try to apply upward force. Clear? At the same time, the fluid particles which are accumulated here, they will apply the downward force here. Clear? So the great part here is the upward force from the bottom and the downward force from the top, both will be equal and both will be almost equal and they will get cancelled by each other. So if they get cancelled by each other, the stem can be easily moved in the downward direction by using the outside pressure. Let us say outside pressure is input pressure. Clear? So the idea is simple here. The particles which are accumulated at the lower end of the second valve plug will be cancelled. In fact, the upward force will be cancelled by the, downward force will be, here it is considered as the upward force. That will be cancelled by the downward force here. Clear? And the problem what we have faced in the previous slide, it is completely overcome in this slide. Clear? Now, let me put the points so that you will understand this in the better way. As you all can see, there are two plugs or two orifice openings in double seated valve, and more importantly, the flow moves upward in one orifice area and downward in the another orifice area. So the resultant upward and downward thrust is almost equal to 0. This is exactly what I mean to say, right? So I have shown you, diagrammatically and explained so clearly here, right? But what is the problem here? See, definitely when you get some advantage, undoubtedly you will get some disadvantage also. So what are going to be the disadvantages here? The very first thing is, let me call this as a valve plug 1. or plug 1 and this is plug 2. So let me say this is the plug 1 and let me call this as a plug 2. Plug 1 and plug 2 both may be made up of the same material, but unfortunately both will have a different expansion because of the temperature. Okay, that means if the temperature changes by some amount, the expansion in the wall plug 1 and wall plug 2 both will not be same. That means one plug will be too much expanded and another plug may not be expanded that much. In that case, what will happen? So the problem with this is, if this is the case, if I want to fully shut down this wall, right, so I may come and apply some amount of the pressure here. If I want to fully shut down, then obviously this may close like this, okay. But unfortunately, if it is, not expanded too much, suppose let us say here the expansion is less, or maybe you can consider that it is compressed, then what will happen? This wall all the way it will come up here, right? So because when the plug 2 is compressed because of the temperature, quite logically plug 2 will become small compared to the plug 1. So the plug 1 will going to obstruct here very happily, but plug 2 will all the way it will come up to here. Then what will happen? Even though you decided to maintain the output fluid flow rate as 0, the fluid may not go here. It may not go in the upward direction, but you will be able to see the fluid will come all the way like this here. Clear? So that means when there is a difference in the expansion of the plug with respect to the temperatures, quite logically, you will not be able to close the valve or you will not be fully open the valve. Clear? So this is the problem with the double-seated control valve. In fact, especially we cannot close the valve. Clear? So I have put that point here. So in fact, you see how we have overcome in this particular example. As a result, the force required to move the double-seated valve is comparatively much less in the case of double-seated valve compared to the first one, right? What was the disadvantage we have discussed? Just now I have told you, due to the difference in temperature coefficient of stem and valve seat, both the plugs can't be rested simultaneously. This is what I told you, right? So there are two options here. One is plug 1 and plug 2. The expansion of the plug 1 is not equal to plug 2. Unfortunately, even the valve seat arrangement, even if you see this one, exactly look at the beauty of this. Here, this one, even this expansion is also not same. So, when the valve 1 or when the plug 1 is completely rested, fully closed, plug 2 will not close. Or when the plug 1 is not closing, plug 2 may close. Because of this reason, it is not possible to fully shut down the valve. Hope you understood this. If you are getting the concept, please keep your comments in the comment section so that will give the energy to me. We can go faster also. So is it clear so far? So far I have explained clearly how we can see the difference in the control valve based on the number of plugs, single seated valve and double seated valve. Is it clear to all of you or not? Of course there is some delay, so I want to listen from you, so please keep in the comment box. Or if you have any doubts, please ask me openly. Today the concept is very small and we may be able to complete in 8:15 or 8:20 maximum. Hope we can complete by that time. So you can interact with me and you can ask whatever the doubts you have. So I'm ready to explain that. In fact, this would be the last lecture on the process control so far. Correct? Any doubts? Is it clear to all of you? Yes. Yes, sir. Yes. Good. So let's go to the next one, that is based on the actuation, how do we divide the control valves? So based on the actuation, the very first type of control valve is pneumatic type control valve, and followed to that the second one is hydraulic type, and the third one is electrical type, that is nothing but solenoid type valve. So what do you mean by actuation? So I will tell you, don't worry. Actuation means by using which amount or by which form you are able to displace the stem. Okay, in a simple language, we have studied up to now so many times, in fact discussed several times, that depending upon the stem movement, the output fluid flow rate will change. But how do you change the stem movement? Will you apply the air pressure to change the stem movement? If so, then that would be called as a pneumatic type control valve. Suppose if you apply the liquid pressure to change the stem movement, then that would be called as a hydraulic control valve. Suppose if you apply the electrical input to change the stem position, then that will be called as a solenoid valve, or we can call that as a electrically actuated valve. Clear? So now moving ahead, so what is the value or what is the range of CV for a pneumatic valve? Very good question, Hari Krishna. I think the answer for this I have explained in the previous lecture. Okay. Otherwise, wait till the end. I will answer this question because we need to discuss elaborately on the CV value for different valves here. Clear? Moving ahead to the next one, that is pneumatic type control valve. So you all can see on the slide, I have explained this even in the very first lecture of the control valve. What we do here is, we will apply the air pressure here. So when we apply the air pressure, all the way the air pressure will be applied on the diaphragm, and then the diaphragm will be displaced in the downward direction. As a result of that, the stem will be moved in the downward direction, and then the plug will automatically close the seating arrangement here, and then the output flow rate will be regulated or reduced here. Clear? So as we are applying or as we are operating this entire valve with the help of air, we call this type of control valves as pneumatic type of control valve. Clear? So as Hari Krishna asked this question, what would be the value of CV for a pneumatic valve? Okay, so it is not possible to fix the value of CV because the value of CV depends upon the area of opening. So how big the area of opening you have, that much big the value of CV. However, we limit ourselves to go for maximum of 100 in the case of pneumatic valves, but there are specific applications where there is a scope to go even beyond that also. Clear? So that's one point, and I have specially seen many times even in the industries the value of CV will be 30, 40, somewhere around that. Clear? Now, what would be the input air pressure that is required here? The first thing is, input pressure may vary from 3 psi to 15 psi. You can even see here the pressure range, as I said, 3 psi to, of course, this is going to be 15 psi. And interestingly, the output range is 0% open to 100% open. Clear? So 0% open means what? It is shut down, right? So let me write down, this is shut down, means it's closed. And 100% open means it's fully open, nothing else. Clear? So this is simple way to understand. Sir, how to draw these diagrams? Is there any technique? No, these were not drawn by me. To be honestly speaking, there is a separate team who are going to draw this, and don't try to sketch the exact diagram because even in your exam, no one will see your abilities of drawing the diagram. Right? So they will look at how beautifully you narrated the explanation and the working of the valve clearly. Okay. Anyway, if you are so happy about the way how the diagrams are written, so I sincerely suggest drop a comment box and I will give the person who drawn this diagrams, you can contact them. Okay. Right. Now moving ahead to the next one, that is hydraulic control valve. So as the name itself, it is suggesting that hydraulic control valve means the overall operation of the control valve will be done with the help of fluid pressure, liquid pressure, in fact liquid pressure. Clear? So that's why we call the actuation is done by the liquid pressure. That means we will use the liquid, especially like water, or even we can use the oil. Okay, so especially in the ONGC kind of industries, or else in any oil industries, they will use the oil as a fluid to use all these actuation methods. Okay, now let me explain how exactly we do this. So here you can see there is a term like pilot port, right? So we will try to allow the liquid to go like this. Okay, all of you please see here. We will try to allow the liquid to go like this, and you can see there is a needle valve here, right? So it is like a screw kind of thing. What we do is we will rotate the screw here. So if you rotate in anti-clockwise direction, then the valve or this plug will come out like this, right? When this is coming backside, then the fluid all the way it will try to enter here. This is the way it will enter here, and it will apply the pressure on the plug here. So you can see here, this can be called as a now piston. Correct? Now what will happen when the pressure is applied here? Naturally this will tend to move right side, right? So when it is moving to the right side, naturally this end also will move in the right side. So let us say it's moving by an amount of X units, right? So now the question is, if the pressure here is P in, right? And if we increase the value of P in here, right? So if we increase the value of P in, then what will going to happen? So naturally this particular position will change here, and now you can see if you have heavy amount of pressure, I must say this will all the way it will come up to here, right? So look at that, it will be moved up to here, and then give me 1 minute time. So this is the way how it looks like, right? So it will come all the way up to here. In fact, the overall piston movement will be X now, right? So this will come up to here. Then as this is not there here, because of the heavy pressure it is moved to the right side, then we can find so much amount of the liquid that will come or that will be flowing through the port A, or so much amount of the liquid that will be flowing through the port P here. So there are two options here. The liquid either can go to the port A or liquid can even go through the port B here when the piston is moving to the right side because of the heavy pressure that is applied by the liquid here. Clear? As we are able to displace the piston and allow the fluid to flow through the different channels here, we call this as a directional control valve, and it would also be called as hydraulic valve because we are applying the liquid pressure. Clear? Now summing up all these things, majorly the input pressure range would be equal to, why only 3 psi to 15 psi? Very good question. Very good question. So in fact it is not a small question. It itself it requires one session on that. Okay, why it is 3 psi to 15 psi? First of all, you must understand that we are working in the process industry and our diaphragm should handle the amount of pressure. So we should not require a very high amount of pressure. We should not require a very low amount of pressure. And there is a concept called level 0 and dead 0. In fact, live 0 and dead 0. So to explain this concept of 3 psi to 15 psi, I require to take at least one section only dedicated to that. If you are interested to listen that completely one section, put it in the comment box and your next section will be that. Why it is 4 milliampere to 20 milliampere standard and why it should be 3 psi to 15 psi. If you really want to enjoy and if you want to enjoy that particular concept and have a clear grip on that concept, please put your comment in the comment box. I will explain separately for that. Okay, because we require to take at least one session for that. Okay, so 3 psi to 15 psi is the pressure range, and for 3 psi it will be 0% open, and for 15 psi it would be like 100% open here. Clear? So the same range even for the pneumatic pressure and even for the liquid pressure we are using. However, the liquid or hydraulic actuators are bulky ones, okay, because it has to handle a lot of fluid, whereas pneumatic valves are not so very big, right? And most importantly, in case of pneumatic valves, we have to purify the air before supplying the air onto the diaphragm. And in case of liquids, we don't face so much of problem because getting a purified liquid is comparatively easy when we deal with the air. Clear? So maintenance is comparatively less in the case of hydraulic actuators. Okay, moving ahead to the next one. Yes sir, ready. Okay, sure. There I am also ready. Surely we'll have one more section on this, like why 4 milliampere to 20 milliampere and why 3 psi and 15 psi. We'll have one session on that. Okay, now coming to the last one, that is the actuation mechanism. Even it can be done with the help of electrical current also. So if you do the actuation with the help of electrical current, then that will be called as a electrical actuator or electrical actuated control valve. And the best example for this is solenoid valve. Now let me take briefly some amount of time to explain this concept so clearly to you. Now have you seen here, valve body is there, fine, and there is a small gap which is called as orifice here. I want you to see clearly here. Okay, so there is a small gap here. This is considered as an orifice opening, and above this opening there is a bulk. In fact, we can see plunger here, and there is a huge amount of stem. In fact, this is also called as a stem. In this case we call this as a plunger, but generally it is a stem. It is made up of a magnetic material. I repeat, plunger is made up of magnetic material. Now you can see this is actually a cylindrical body. Okay, this is a cylindrical body, let me say, in the upward direction, and inside the cylinder we have the plunger, and outside the cylinder we wind the cylinder with the help of coil. Suppose let us take this one as an example. This is the outside cylinder, and what we do is we will wind the coil like this, an inductor. Okay, and when the coil is winded all the way, it looks like an inductor, and inside this cylinder we will have a plunger, or you can consider like a stem, magnetic material. What happens is the outside coil terminals will be taken and it will be supplied by the electrical voltage. That means we will take this one. So see here, even here also, and here also you can see all the way this flux will come here, and let us say I have applied some amount of voltage here. If I apply some amount of voltage, undoubtedly there will be some amount of current that will be flowing here, right? And this current, it may enter here, because I told you that this is a coil, so it may enter here and it may exit here. So the current all the way it will come like this and circulates in the coil, and finally it will come out here. Clear? So this means on the outside winding, the current is traveling through the winding all the way. Now when the current is traveling through the outside winding, what will happen? Inside we will be getting the magnetic flux. As we are getting inside magnetic flux, in fact, if you ask me or if you have patience, I will explain this in much more clear way, because this is very important. See, this is the way, look at that, our coil is there, right? So look at that, like that. Let me take like this. Now when the coil is winded like this, the current all the way travels through this one and then come here and again come here and then come and finally comes like this, correct? So when the current is traveling through the coil all the way, undoubtedly huge amount of magnetic flux will be developed, right? So let us take huge amount of magnetic flux means there is a huge amount of magnetic flux that will be developed inside the coil like this. Now when the huge amount of magnetic flux is developed inside the coil, what will going to happen? The magnetic material which we have named as a plunger, that will move in the upward direction, right? So that means, let me remove all these things now so that you will understand this clearly. Yes, so you can clearly understand at the end or at one end of the plunger we have a spring here, correct? So what happens when the magnetic flux pulls this plunger in the upward direction? Naturally the plunger will go in the upward direction. When the plunger is moving in the upward direction, huge amount of opening is there here, so the liquid all the way it will try to displace like this. So that means it will come like this and flow in this way. So when we increase the value of current here, look at the beauty of this. When we increase the value of current here, then the amount of the magnetic flux is increasing, and when the magnetic flux value is increasing, then the stem movement or the plunger movement is in the upward direction. When the plunger is moving in the upward direction, the area of opening at the orifice will increase. When the area of opening at the orifice is increasing, then the output fluid flow rate also will increase accordingly here. Clear? This is very simple physics, isn't it? And reverse also same. Suppose if you decrease the current, then naturally what will happen? The amount of the flux will going to reduce, and when the amount of the flux is reducing, the plunger will not get attracted too much, so the plunger will move in the downward direction and the area of opening will reduce and the fluid flow rate will reduce. Ultimately what should I say is, the more the value of current here, you will be getting more amount of the output fluid flow rate. Clear? Suppose if you reduce the value of current, the fluid flow rate is going to reduce. So in a single line, what should I say is, current is an electrical variable, correct? Of course, current is an electrical variable. Ultimately, we are getting the fluid flow rate as the output variable here, right? So this means the current is getting converted into the fluid flow rate. So the electrical variable is converted to mechanical variable directly without intervention of any other technical variables. That's why people are so crazy about the solenoid valve. So those students who are watching continuously, if you understand the concept of solenoid valve clearly, please answer yourself here. Tell me whether it's clear to you or not, solenoid valve. If you say yes, it's clear, we will proceed to the next one. If you say you have some issues with the solenoid valve, once again I am ready to explain this concept. But I feel that I have communicated everything that is required as per the student's point of view. So please let me know, is it clear or not? Well, now moving to the next topic, that is directional control valve. What do you mean by directional control valve? Yes, clear sir, clear, very good. So what do you mean by directional control valve? Directional control valve means the valves are the control valves which regulates the direction of the fluid flow rate. In fact, in the very beginning class, I have told you that, right? So if suppose if you have a pipe like this, assume that here there is a control valve and there might be two pipes connected here, okay? So there might be a chance that the fluid will flow this way, and we want the fluid to flow in this way for some time. After some time, you want to allow the fluid to go in this pipe, correct? So if you want to change the direction of the fluid flow so continuously, you require the directional control valves. So among the directional control valves, the very first one is considered as a check valve. Check valve is a basic type of directional control valve. In fact, we call that as a unidirectional control valve. Now let me show you how exactly it looks like or how exactly it will operate. So give me some time. Let me draw this one. Suppose let us consider a cylindrical pipe like this. Okay, so if I take wall plug like this, suppose let us say, or else even you can take like this also. Suppose there is an obstruction here, we can consider like this. And what we brilliantly do is, we will have a disc mechanism here. So look at that. This would be considered as a solid disc, disc basically. And here there is a spring that will be attached to this. Clear? So I have drawn very little diagram, but I feel it is communicated, right? So what happens here is, when the fluid comes here all the way, it will try to, let me take another color here. Yes. When the fluid comes all the way like this, it will try to apply huge amount of the pressure on the disc here. So let me call this as a check disc, right? So this is called as a check disc. What happens is, when the pressure is more here, naturally the disc will move in the upward direction. That means when the disc is moving upward direction, how it looks like here? So this will not be the shape now. When the pressure is more, logically the spring will going to compress too much here, and our disc is like this, correct? So it is open. Now when it is open here, then obviously the fluid will try to go through this path, correct, to the outside. So it is like a check post. Have you ever visited any check post? Right? If you want to travel, or if you want to have your journey between two separate states, then obviously you need to go through the check post, right? So the check post and the check wall both are, similar kind of thing. But the problem with this is, you can all the way pass the fluid like this, no problem. That means if I call this as a 1 and this is 2, the fluid can flow from 1 to 2 very easily if the pressure is more than the spring resistive force or spring resistive energy. But have you identified this problem here? In the same diagram, suppose let me redraw the diagram once again for you, right? Suppose if I say, look at that, and here we have the wall like this, isn't it? This is our wall, correct? So suppose if I allow the fluid to flow in this way, let me take another example here. Is it possible to go like this? Suppose if you apply the fluid with a high amount of pressure, it's not possible for the fluid to travel from the second terminal to the first terminal, or second port to the first port. Fluid can flow through the first port to the second port. That means left to right it is possible if the pressure is more than the spring resistive force. But right side to left side it is not possible. That's why it is called as a unidirectional control valve, and it is a basic type and famous type. Is it clear to all of you? Yes, good. So basically the idea is so simple. If you want to allow the fluid only in one direction, we require the check valve. Now moving ahead to the next one, that is shuttle valve. Shuttle valve is called as a bidirectional valve. See, I am taking a most famous type of control valves. As I said at the starting itself, there are n number of types of control valves are there, and it's not possible to go through all these things. Sir, will you teach full control systems? Full control system I will teach, but not on YouTube. It will be taught to you in the paid lectures. So if you want me to take the control system classes, you can keep your demand here. Definitely the management will note down that and they will address that. Okay. So the shuttle valve, it looks in a simple way like this. Now you see here in the shuttle valve, how many ports are there? Two different sources are there, right? So instead of source 1, let me use the word like inlet 1. For easy understanding, even if you write like source 1, nobody will go into object you. And source 2, let me call this as a inlet 2 here. Okay, inlet 1 and inlet 2. And for time being, let me call this side as an outlet here. Clear? Interestingly, there is a small rally here, so we will be having. Alright, so let's look at like this, in this way. A small shuttle here. This is called as a shuttle here, right? Or even you can take this shuttle as an example here, right? For example, what happens is, or else you can take completely like this here, shuttle. Now I want to ask your question here. So let me take a simple table here, that is inlet 1 and inlet 2 here. And for time being, let me call this as a outlet here. Clear? Easy to understand. What happens here is, suppose let's allow huge amount of the fluid flow rate from the source 1. Means inlet 1 is activated 1, and there is no fluid that is going through or that is allowed from the inlet 2. That means there is no fluid here. So only the fluid is passing from the left side to right side. right? In that case, it would be called as a 1, 0. What would be the outlet here? Any guess from your side? Any guess from your side? Will you get the outlet or will you get any fluid through the outlet? Yes, because the shuttle will all the way travel like this. So this shuttle will travel like this, and it will reach to this end immediately if the pressure is more. That means by the time when the fluid try to come from the left side, the shuttle will displace easily and it will come up to here. Clear? It will all the way, it will come up to here. Correct? Then what will happen? The fluid can come all the way like this, and you will be able to find the fluid at the outlet channel. So that's why I can say 1, 0 will make 1. Clear? Now the beauty of this is, have you ever think about this one, right? So let me take this in a simple way like here, so that it would be, because you will be able to see this 1, 0, 1. Now let's see the other situation. Suppose if you don't allow the fluid here, and assume that you have applied the fluid here, okay, this side. That means the fluid is coming from the right side to the left side, right? Yes sir, interested sir, optical instrumentation. Okay, very good, right? Sure. So it's a very big message. I really appreciate to you to write this much of big message. But sincerely, again, I am saying the same point, that if you want any support from the BYJU'S team, especially in instrumentation, once the live section is completed, okay, without any laziness, you just drop a message in the comment section so that the team will understand your demand. Okay, right? So that when the fluid is applying, or when the fluid is allowed to travel from the left side to right side, what will happen here? So obviously this will travel in this way, correct? Look at that. So that means the shuttle is forced to come up to here, correct? The shuttle is all the way, it is forced to come up to here. When the shuttle is all the way forced to come to the left side, naturally the liquid will all the way travel up to here. Clear? Right. So then I can say, even if I don't allow the fluid in the first case, right, 0, and allow the fluid in the second case or second inlet, and I am able to see some kind of output here. Clear? So don't worry about the session, because so many students are asking me the question when the paid classes will start or when the subjects will be taught, all these things. At the end of this lecture, I will provide my contact details so that you can be in touch with me for the regular updates. That is the one single favor I can do, okay, immediately, okay, right. So this is about the second one. And now I would love to ask this question. In case if both the sides pressure is on, right, so that means if the fluid is on here, right, if the fluid is coming this side and even this side, then what will happen? The shuttle will stand somewhere here, correct? So the shuttle will stand somewhere here, okay, because there is a small support here, grill kind of support, right? So it will stand exactly in the middle. Then I can say the fluid can all the way come here, and even the fluid can come like this. This means that if it is 1 and this is 1, this would be 1 here, correct? So let me take this as 1 here, and this will be 1 here, right? Now the last point is, suppose if the pressure or if the fluid is not allowed in the inlet 2, and if the fluid is not allowed at the inlet 1, if there is no fluid anywhere, then what does it mean? It means that 0 here and 0 here, and that will be 0 here. Clear? So now look at this table here and tell me what kind of table this represents. Is it OR gate or AND gate? Any one of you? Or I'm very happy if all of you can answer this one. Okay, so is it OR gate or is it AND gate? Which is this type of gate? Okay, look at the table and answer to me. I'm waiting for you. Well, OR type or AND type? Good. Good. So this is basically the OR logic gate, correct? So this means that we can execute digital logic even with the valves or control valves also. This is called as OR logic here. I hope you understood this. This is very easy to understand. Now moving ahead to the next type, that is dual pressure type valves. So this is also a bidirectional valve here, right? Yes, very good. OR gate, nice. So dual pressure valve is also a bidirectional valve. Now if you see the construction, it looks something like this. So it's very easy. Now let me take the same table here because it's done already, and we have concluded clearly that shuttle valve represents the OR logic here. So let me write down this as OR logic here. Those students who want to enjoy the field of instrumentation, I think you are on the right track, you are on the right platform. So stay connected to me till the end of your examination. Definitely you will get a lot of benefit out of this channel. Okay, dual pressure valve. What does it mean here is, even now you can see inlet 1 is there and inlet 2, and this would be considered as outlet here. Clear? Now you think about, you think about this diagram clearly and get the concept by yourself. Then it will be very interesting here. Suppose, let's say the fluid is applied, or we are allowing the fluid from inlet 1. Means immediately I can write down 1 here, right? And there is no fluid from inlet 2. Okay, for example. Then what will happen? If the pressure is more, then this will come all the way and close here, right? When it is closed here, look at that, whether any liquid can come out like this? No, right? So it is closed here, even it is closed here, right? So the liquid will not be able to come outside. So therefore it would be considered as 0 here, correct? Now similarly, let's assume that we are applying the pressure from this side, or allowing the fluid to flow from this side. Then what will happen? If you apply the pressure here all the way, I am very sure this will move up to here and it will try to close exactly here. So 1 second. This plug all the way it will close exactly here, because the excessive pressure or heavy pressure from the inlet 2. Then what will happen? This is a rod simply, and I am very sure that, so at that time you can see this will come all the way up to here. If you allow the fluid from the left side, then again the fluid cannot find any path, right? So it cannot go here or it cannot come like this, right? So this means even if you allow the fluid only through inlet 2 and if there is no fluid passes through the first inlet 1, even then you will not find any output here. So the output is 0. And anyway, if you are not allowing the fluid through any of the passages, then at that time also it will be 0, right? Now look at the beauty of this. Just allow the pressure from both sides. Assume that we are allowing the pressure from both sides, and fortunately the pressure is same. That means, look at the beauty of this. I am allowing the fluid from this side here and even allowing the fluid from this side also, right? So that means P1 is allowed and P2 is also allowed. Fluid is actually coming from both the sides. Then what will happen here? Interestingly, if pressure is there from both sides, let me say huge amount of pressure here, so let me call this as P2 here, and here also huge amount of pressure, so let me call this as a P1. Now what will going to happen? Any guess from your side? So now you can see, as P1 and P2 both are same, quite interestingly this will be stopped in somewhere here. So look at that. So let me take, okay, so the diagram, let me redraw the diagram like this. So it will be somewhere like this, and exactly there is a middle connection here, right? And even you can find this, let me take here itself, okay? So now you tell me whether the fluid can flow through this or not. Yes, of course. Now the fluid whatever is there here, right now it can all the way travel like this, and the fluid which is there here, it will travel all the way like this here. Clear? So easy to understand. This means that if the pressure on both sides is same and if the fluid is allowed from both the inlets, then the output will be equal to 1. What kind of logic this is? Anyone? Look at this table and tell me what kind of logic this is, right? So this is clearly states that AND logic. Am I right? This is clear AND logic. Hope you understood this. So shuttle valve performs OR logic, and the dual pressure valve performs, or it can function as a AND logic. So is it clear to all of you? Yes or no? So please answer me so that I will understand. Okay, so this is going to perform the AND logic. So easy, isn't it? That's why I say whenever you are studying any particular subject, if you keep your heart and soul in the subject, then the subject looks very easy and beautiful, right? So with this, the directional control valve basic types are completed. Yes, shuttle valve behaves like a OR logic and dual pressure valve behaves like a AND logic. Clear? So with this, I have completed almost what is there for the GATE syllabus. But as you all know, I will always move one step even beyond the requirement. Let me go one step beyond the requirement and take the class for another 5 to 10 minutes. Okay. So we will see the next level of construction, that is control valves based on the construction. So it looks very simple, right? So there are two different types of classification. One is a linear type control valve and the second one is a rotary type control valve. What happens in the case of linear type control valve is, look at the stem. This is a stem here, and let me take this as a plug. Clear? So stem and plug both are like this. In case of linear type control valve, the plug will move linearly downward direction or it may be upward direction because of the positional change in the stem. That means the plug either moves in the upward direction or downward direction. That means linear motion of the plug is allowed. I repeat, linear motion of the plug is allowed. However, if you see the rotatory type actuators, now in the rotatory type actuators what happens is, we will be having like, you know, a kind of disc or anything here. So let me take the plug shape like this, right? So now the plug will rotate here, clear? So it will not move up and down, it will rotate like this. Suppose if I take, this is a stem here, okay? Assume that this is a stem and this is the plug. This is the plug and this is stem. So it will all the way rotate like this, clear? So that means the plug will rotate. It will not displace up and down here like this, rather it will going to rotate like this, clear? So I am sure many of you might not understood this exactly. So let me take some animation and show it to you so that you will understand. So I have taken two different types of, you know, linear type of wall. One is gate wall and second one is a globe wall. So what do you mean by gate wall here? So simple. So I hope you can see easily in the picture, and I request please see the animation. Have you seen here, when you rotate this one, right? Look at this. Look at the animation, such a beautiful animation, isn't it? So you should appreciate the person who designed these animations. My subject matter experts, they are really, you know, very hardworking. They have made all these things. So please appreciate them. So now you see how exactly it is rotating here, right? So when the wall, when the stem is moving up, in fact, this is where the point we will rotate it here, right? So when we rotate this wheel, the stem will move in the upward direction or downward direction. Focus only on the animation, I am sure you will understand, right? So this is how it will be either closed fully here, or if you reverse that, you will be allowed the fluid to flow this side, clear? So that means the plug is going down or up. That is the beauty of the gate wall. Of course, if you want the internal construction, so it's a very huge topic as I said, right? So this is the main part I am discussing, that is body. In fact, we are going to have a disc, and that can go down or it can go up. And most important thing I would like to say here is hand wheel is the one which we will try to rotate in process industry, and you can even see the stem here. Most important thing is bonnet. Bonnet is nothing but the total shape in which all the parts of the control wall will be protected here. Sir, should we know the construction material? Or to be frankly speaking, for the gate level you don't require to know, but of course when you are working in the industries, as material of construction is very important, at that time you should know, because based on the requirements sometimes we may require to change the material of construction, clear? So this is about the gate wall. But if you see the globe wall, right, even the globe wall also looks like that only, right? So see the animation and try to understand from the animation. Even here also, when we turn the wall, right, so then obviously what is happening here? So one side, if you turn, this is moving up, right? So and that time the fluid will all the way happily, it will come from the left side to right side. But suppose if you return the, or if you reverse the direction, then it will close and the fluid will be stopping here, clear? And if you look at the construction, more or less everything looks same, but the only difference is the plug and little bit constructional difference according to the shape of the plug, clear? These two are going to be called as a, you know, linear type walls. But as I said, there are n number of walls are there even in linear type also, because it's countless. You will go for unlimited walls, okay? But basic types I am explaining. Now moving ahead to the next one, that is rotatory or rotary type control valves. One among that is the ball type. Now you can see such a beautiful diagram here, right? So there is a gap here in the plug, right? So what happens is, when we turn this handle, so usually there will be a handle like this, right? What we do is we will turn this handle. When we turn this handle, then it will rotate like this, right? When it rotates like this, this is exactly the way how it looks like, clear? So what happens here now? So the fluid can all the way flow through the hole that is present here, and I can say it will come all the way like this, correct? So this can be considered as a fully open state. But in this case, you see, when the fluid comes all the way like this, so it will hit the closed part of the disc or closed part of the plug. So when the fluid is all the way coming up to here, it will hit here. Unfortunately, the fluid cannot come to the outside. So this is considered as an off state here. So let me say off state, and this would be considered as an on state. Means the entire amount of the fluid that is flowing through the fully open. In fact, this can be considered now as fully open here, because one second, it can be called as a fully open. As I was saying that the whole of the plug is facing the, you know, fluid path. So the fluid will happily flow through the plug here, correct? Now coming to the last one, that is butter type valve. In fact, butter type control valve. Now you can see here again, Follow the animation. How exactly it looks like? The disc is actually rotating inside, right? So now see the beauty of this. Again, please show the animation, right? So this will flip like this. Clear? So tomorrow's schedule, tomorrow we are going to have live interaction with the BARC scientist. Okay? BARC scientist, of course, from the instrumentation stream. However, he would like to give a clear explanation about his journey as well as the work culture in the BARC and his preparation tips also. So we will meet at 9 o'clock tomorrow to discuss and interact with the BARC scientist in live. So whoever are interested, they can join with me, no problem, right? Enjoying a lot. Thank you very much. Thank you. Right? Now, I would like to say, this is the animation. So you can easily see when the disc is rotating here, sometimes it may close the opening and sometimes it may unclose the opening. Now for the more clarity here, you can even see the disc here. Clear? This is the disc. Now when the disc is at semi opening space, then obviously the fluid can all the way flow through the middle gap here. So let me take clearly here, it can flow through the middle gap here. Fluid can all the way flow through this one. So it's very easy. Just assume that this is a hole, right? This is a pipe and this is a butterfly plug. So it can close like this, right? If it closes like this side fluid cannot come to this side. But suppose if it is rotated like this, then what will happen? This is the way how it closes, correct? So now you can see clearly there is an opening here and here. So definitely through the opening the fluid can come from that side to this side. Suppose if I rotate this and close this way, right? So then what will happen? If it is exactly like this, look at only this plug, right? So otherwise look at this one. So if this is the wall plug, exactly if it is here, then obviously the fluid from that side, it can come to this side. Suppose if you rotate like this and close this, then the fluid cannot come to the one side to the other side. Clear? So in fact front side to back side. So that is exactly how the butterfly valve will work. So I have explained the concepts of linear type control valve and I have even explained the concepts of rotary type control valve. With this, the basic types of control valves are all are completed. In fact, I have thought even one step beyond the GATE examination, keeping in the mind about the interview requirements also. Okay. Hope I have communicated all these topics as it was the last class and as I found that many students are eagerly waiting for instrumentation, I sincerely suggest only one. If you are really interested to enjoy and explore the core concepts of instrumentation, just drop one single message in the comment section once this live session is completed and the team will contact you and you can both discuss about what are the requirements to get the admission here. So once again, I am really very happy to teach all of you. I have completed the major demands of the students and again I am saying if you have any particular demand or any particular requirement in instrumentation, just drop one message below the YouTube live section. Obviously, team will contact you and we will take the next live section based on your demand. And ultimately, at the end, I would like to thank BYJU'S Exam Prep platform for giving such a wonderful opportunity to explain the concepts to the instrumentation students. Hope you have really enjoyed the section very well. We will meet with the new topics in the upcoming sessions. Thank you very much.